Okay, worksheet 17 help. Now, anytime you program a PLC, if you're me, you try and plan ahead a little bit. Because if you don't plan ahead a little bit, sometimes getting on the software, you can get overwhelmed. So what I did before I even started programming for worksheet 17 is I went in and said, okay, I'm going to use two timers. One for my normal cycle, one for my blink cycle. So timer 1 is my normal cycle, timer 2 is my blink cycle. And so it's going to go from 0 to 1, which is actually going to be 999, is how logically I'm going to do it. I'm also going to let this timer count in milliseconds. I have this in seconds, so I got to always remember to move my decimal 3 decimal places in order to make it work. And that will become apparent later. Okay, so I want red from 0 to 1. I want red-green from 1 to 11. Red-yellow 11 to 15. Red-red 16 to 17. 17-27 green-red. 27-32 yellow-red. And then I want it to automatically repeat. When I'm in the blink cycle, I set it up 3 seconds. Or we'll set it up 3 seconds. Or 3,000. Where I'm off initially, and then red yellow for the last second and a half. Okay, so I set up that. If you try and duplicate this and set up a spreadsheet, you're going to have to go in and format this as a text. Otherwise, it will try and turn all your numbers into dates. So you want to format the cells as text, and then it will show up, and you can actually duplicate this. Okay, so I want a stop-start circuit, which I don't know if this ties in exactly with what I've got, and I didn't comment. I expect comments on y'all's programs, but this is my stop-start, pretty obvious. And then if C5 is on, my cycle is on. I want T1 to time. Same comment as last time. DS1's my set point, so you actually have to put a number in DS1 and send it to the PLC in order to get it to work. You could put the number in manually if you wanted to. That's fine. It's up to you. If my cycle is on, then and T1 is off, then T1 starts. When T1 gets done, it will reset itself. So as long as the cycle is on, this timer will just time to 32 seconds and reset. 32 seconds. I did leave my time base as milliseconds, and I'm non-retentive, which is the default. When my cycle is off, then T2 becomes true, or can be true, and it will time for whatever I've got set in DS2, which should be 3,000 milliseconds. When T2 gets done, it will reset itself. So fairly straightforward rungs here. Eventually I'm going to add a police switch. My police switch is C3. If C3 is on, I'm enabled to do the normal cycle. When C3 is off, I want to do the blink. So C3 also kills my normal cycle. So I can either stop my normal cycle with the stop button, or I can stop my normal cycle with the C3 button. And that will make this timer work. Okay, now outputs. Our outputs on my HMI are C10, 11, 12, 13, 14, and 15. If you consider C10 to be north-south red and C13 to be east-west red, then what I've done is I've gone in here and populated one of the rungs. So I want north-south red to be on for these first 4 timers. So they will go through 17 seconds. Now, one of the things you got to be careful of doing comparison statements is that when a timer is off, it's going to go to 0. So my TD1 is greater than 0 for this to be true. So if my timer's off and my TD1's sitting at 0, this will still be false, which is one reason why I let it time in milliseconds, because it will come off 0 in a millisecond if it's timing, in which case that will be true. And so it will all happen in a millisecond, which is very fast from our perspective. So basically what I'm saying is, if TD1 is greater than 0, which is 000 milliseconds, and less than 17,000 milliseconds, less than 17,000, so this means this will be true to 16,999. Then turn on C10, which happens to be my north-south red. The other logic I did was east-west red, which is on for the first second, and then it is on from 17 through 32. So again, I did the same logic. TD1 greater than 0 and TD1 less than 1,000. So that will get me on for that first second. And then when I get above 16 seconds, greater than or equal to 16 seconds, then I will turn on that red light. So that's that logic. Okay. Alrighty. Green logic, just as an example. After the 1 second, I want my east-west green to come in. East-west green is output C15. So I want it greater than or equal to 1,000, less than or equal to 11,000. So on the upper end, I'm using less thans. On the lower end, I'm using greater than or equal to's, except when I'm referencing 0. Then it's just greater than. And I'm being pretty consistent, and I have found that works best. Okay, and I like my timers to time in milliseconds, so all these should be in thousands. Okay, so that's what I wanted to show you there. So that should get my green light on. Alrighty. Now, what about my blink cycle? I want my red light on during my blink cycle, which will mean TD2 is greater than 1,500 milliseconds. So what I did is I took my north-south red and I just ORed TD2 in there, greater than or equal to. And then my east-west red, I did the same thing. I've got its logic, and then I went in and said, okay, this one will be on when the cop switch is made, in which case I'm turning it off. So again, TD2 will be on if my police switch is switched and my timer 2 is greater than 1,500. So I wanted to show you that. And there's the timer 2 accumulated. So that shows you that logic. Alrighty. Let's go back one. Okay, now what you've got here is you've got logic for your north-south green, which you can just go figure out when north-south green is going to be on. It's going to be greater than 17,000, greater than or equal to 17,000, less than 27,000. That should be fine. That will turn on your green, which is 12, and then 11, which is the yellow, will be 27 to 32. Since your timer resets, all you really need is the bottom, the greater than or equal to 27,000, because it's gonna reset and it's gonna loop around. So you don't need the less than or equal to 32. I mean, you can add it if you want to, but you really don't need it in your program. So I've left that for y'all to put in, figure out, comment, and that's that one. So that will give your stoplight based on comparison statements. and the outputs. And we'll really have fun with the next one. Thank you for watching.